in 1.3, we're going to investigate linear relations and equivalent linear systems. Okay, so just to recall, a linear system, what is that? That's when we have two lines and we want to know, do they intersect? Okay, so on the same grid, graph these two lines. We should already know that when we have lines and we need to graph them, we need to put them into y equals mx plus b form first, which is called slope y-intercept. So let's bring the x over. We have 2y equals, I'm going to actually put the x right in here so it's in order, negative x plus 4, and I'm going to go ahead and divide each term by 2. Okay, so we get y equals negative x over 2 plus 2. The slope is negative 1 over 2, and the y-intercept is 2. So y-intercept's 2, and we're going to go down 2 over 2. Or sorry, down 1 over 2. Down 1 over 2. Down 1 over 2. Okay, now the next one, let's actually connect those. Okay, so that's x plus 2y equals 4. Now, the next one. 2x plus 4y equals 8. 2x plus 4y equals 8. Let's bring over that 2x. We're going to have 4y equals negative 2x plus 8. Now let's divide each term by 4. And we're going to have y equals negative x over 2 plus 2. Okay, so m equals negative 1/2 and b equals 2. So take a look here at both of the m's and both of the b's. We're going to again start at 2, and we're going to go down 1 over 2. Down 1 over 2. Down 1 over 2. And what do we notice? We notice that these two graphs, these two equations, actually represent an equivalent graph or an equivalent line. So let's think about this. How are the graphs related? Okay, the graphs are, we can say equivalent, or we can say the same. Okay, that means these lines are collinear. What does that mean? That means that they share a line, linear line. Okay, so now let's go ahead and solve the same system by using substitution. Okay, we learned substitution in 1.2. So let's go ahead and solve that using substitution and see how that looks. Okay, so the two equations are x, here we go, plus 2y equals 4, and then we have 2x plus 4y equals 8. And just looking at these, you should actually be able to notice that the number in front of x is now times by 2. The number in front of y, 2, is multiplied by 2, and the constant term is multiplied by 2. But let's see what that looks like if we're using substitution. Okay, so x equals 4 minus 2y. Let's go ahead and sub that in to where that x is. So we have 2, 4 minus 2y. Sorry, my stylus pen. Plus 4y equals 8. So when we distribute this 2 into the bracket, we're going to get 8 minus 4y plus 4y equals 8. Well, this negative 4y and this 4y cancel out to 0. And if we, like the 8 and the 8 are balanced, but if we want to bring that over and become negative 8, we're going to have 0 equals 0. Well, of course 0 equals 0. It's always going to equal 0. But when we have a situation like this, we know that there are infinite, so therefore there are infinite solutions. Okay? And now 4. How are the equations related? So the two equations are multiples of one another. And that's how we are able to recognize if there is more than one solution. Linear equations, what are those? Those are equations that have the same graph. Okay, and equivalent linear systems, and again, a linear system is two lines, and then we consider them at the same time. So these ones have the same solution. So the graphs of linear relations in the system have the same point of intersection. Okay, note for any linear equation, an equivalent linear equation can be written by multiplying, and we talked about this, the equation by any real number. So if both equations are multiples of 2 of one another, or even like a third of one another, okay, then they're going to be equivalent linear equations. So example 1, which two of the following are equivalent linear equations? So in order to solve for that, what we have to do is we have to put them into all of the same form. So the easiest way is, let's put them into y equals mx plus b form. Okay, so in the first one, let's bring over that 5 and let's bring over that negative x. And we get y equals x minus 5. Okay, in the second one, all we have to do is divide by 2, and we get y equals x minus 5. Okay, and then the third one is already in that form, so y equals 3x plus 15. Okay, so if we take a look, the first two are completely equivalent. Okay, so 1 and 2 are equivalent. Okay, when we simplified them, they're exactly the same equation. So it looks as though the second equation was just simply multiplied by 2 of the first. Okay, do not get this confused with, I see that like this is 3x and that could be multiplied by 3 as well. But the issue is the y would have to be multiplied by 3, which it's not. Therefore, the third equation is not equivalent to either 1 or 2. Okay, example 2 is asking us to write an equivalent linear system by adding and subtracting the original equations. So simply, if we add and subtract the original equations, we're going to get two equations that are equivalent. So I'm going to show you how to subtract, and this is going to get us ready for elimination, which is tomorrow. So 3x minus 4x, I get negative x. Y minus negative y, I get 2y. And 19 minus 2, because essentially this is in brackets and we're subtracting each term. So 19 minus 2 is 17. Okay, next one, let's add. So 3x plus 4x, I get 7x. Y plus negative y, that's nothing. And then 19 plus 2 is 21. Okay, if you look down here, these two are the originals. And then these two are the new equations when we added and subtracted the original equations. So what we're going to do is we're going to use substitution to ensure that these two linear systems actually have the same solution. So to me, the easiest to get by itself, let's deal with the 4 and the 2 rather than the 3 and the 19. I'm going to move that negative y over and this 2 over. So I'm going to get 4x minus 2 equals y. Okay, let's sub that into the first equation. 3x plus 4x minus 2, and then equals 19. So 3x plus 4x is just 7x. And I'm going to have 19. I'm going to bring that negative 2 over. It's going to be plus 2. So we can just simply do plus 21. Okay, divide both sides by 7. We have x equals 3. And then let's plug that back in to the expression that we have for y. Y equals 4, 3 minus 2, which is 12 minus 2, which is 10. So the solution I get is 3, 10. Okay, now let's do the exact same thing, Let's use substitution to solve for the second linear system. So we already have 7x equals 21. There's no y in that, and that actually looks a little bit familiar from the previous one. So let's go ahead and find that x equals 3. Now, let's sub that into the second equation. We have 2y minus 3 equals 17. Bring that negative 3 over, it becomes plus 3. So we get 2y equals 20. Divide both sides by 2. I get y equals 10. Okay, so therefore, the point of intersection of both of these, we can see, is 3, 10. And that means that we just showed that when we add two equations and we subtract two equations, the new linear system is going to have the same solution as the original linear system. So at the bottom, I just have a little conclusion. So equivalent linear systems can be written by either multiplying the equation by any real number or adding and subtracting the original equations.